So what we're doing today is just the reverse of what we did on Tuesday. So on Tuesday we had pictures of graphs, and then we were looking at the pictures of the graphs, we were writing the equations. Today we're going to start with the equations, and then we're going to draw the pictures of graphs. We're just going to do little sketches. So these aren't too difficult once you recognize like what the patterns are and things like that, and that's what we're going to look at first. So the first thing we need to look at is like what's the overall shape of the graph, and you start with the degree of the polynomial function. So there's two ways a polynomial function can be written. So one way is you can write it as like y equals x to the fifth minus 3x to the fourth plus 2x squared plus 1. Or, so we've seen problems like this, right? This is when we were finding characteristics of functions, and we were finding like the domain and the range and the max and the min and stuff like that. We were finding them with these types of functions. Or they could be written in their factored form, which is kind of how we were writing them the other day when we were starting with the picture of the graph, and then we were writing out like the x-intercepts and what the multiplicity of those x-intercepts were. So the other way that those polynomial functions can be written is you could say like maybe it's got a negative in front of it and the graph is upside down, and then maybe it had an x-intercept of like positive 5 with a multiplicity of 3 and an x-intercept of negative 2 with a multiplicity of 2 or something like that. So we can see two different ways of writing these equations, and they're both polynomial functions. They're both going to look like a graph where it kind of swoops up and down multiple times, so those kind of curvy graphs. And both of these graphs actually have a degree of 5. So the degree of a polynomial function is the highest exponent. The highest exponent. So this form of the equation is called the standard form. This is the standard form. And that was the form that we had dealt with before when we were finding all the different things we could find from a graph. And when you deal with the standard form, it's all kind of expanded out, and you just look with your eyes and you can see what the highest exponent is. It's really easy to recognize. Typically, the highest exponent is the very first exponent in the problem, because we usually write the exponents in decreasing order. Usually the highest one goes first, and then they go down from there. But sometimes they could put the problem out of order, and then the highest exponent would be like somewhere else in the problem. You just have to look for it. Over here, we have the factored form. Sometimes they call this linear factorizations. So the key word there is just factor. Factors are always written like in parentheses like that. And when it's written in factored form, you don't look for the highest exponent. You have to add the exponents together. So you're not going to see the highest exponent in the problem. You find the highest exponent by adding the exponents together, okay? So I'm going to write that off to the side. Find highest exponent by adding exponents together. So in this problem, you would find the degree of the equation by adding 3 and 2 together. 3 plus 2 is 5, and so this equation would have a degree of 5. Okay? Now, this next part we have kind of talked about already, so I'm going to skip this for a second. We talked about multiplicity. Do you guys remember that? Multiplicity of 1, multiplicity of 2, multiplicity of 3. So we said with a multiplicity of 1, we would have an x-intercept, and the graph would go straight through. Straight through. That's what it looks like when you have a multiplicity of 1. If you guys remember what it looks like when you have a multiplicity of 2, you would have an x-intercept, and it would bounce for that x-intercept. That's what a multiplicity of 2 looks like. For a multiplicity of 3, at that x-intercept, it kind of squiggles as it goes through. So you have two options. It could go up and level off and go up, or it could go down, level off, go down. Those are your two options. So we've got multiplicity of 1 where it goes straight through, multiplicity of 2 where it bounces and doesn't go through at all, or multiplicity of 3 where it goes through but it kind of squiggles as it does it. So this is what's happening at each individual x-intercept. This is like if you zoomed in on the graph and you were looking at what happens when I cross the x-axis at each individual crossing. If we go back up here, we're saying what's the general shape of the graph? So what's happening if I zoom out? What's happening if I zoom out and I look at the overall shape of the graph? So we've got basically two options. Linear is probably never going to happen. We're never really going to look at linear. So quadratic graphs are going to be anything that ends up having a degree that is an even exponent. So that means that even exponent is a degree that ends up being even. So maybe our highest exponent or our degree could end up being 8, or maybe our degree ends up being 4, or maybe our degree ends up being 6. Then the overall shape of our graph is going to be a quadratic shape. So the overall shape of our graph is going to look something like this. So there could be some squiggles in the middle, but overall we're going to have a U-shaped graph. Or maybe the U-shaped graph looks like this. So again, there could be some squiggles in the middle, but if we were to zoom out, overall our graph would be U-shaped like that. So this is just saying if we were to zoom out, what would the overall shape of our graph be? So this is if the degree was like 4 or 6 or 8, something like that. Our graph is going to overall be a cubic shape if we end up with a degree that's odd. So if we end up with a degree that is like 5 or 7 or 9, something like that, then we're going to end up with a cubic shape. So that means we're going to end up with a shape that overall does this. So it could have some squiggles in the middle, but if we were to zoom out, we're overall going to see this shape. Or it might end up looking something like this. If it had a negative in the front, it would go the opposite way. So here, we're not looking at individual x-intercepts, we're looking at the graph as a whole. It does the same thing as the individual x-intercepts, but we're not zooming in, we're zooming out. Okay? All right. So end behavior, you guys know what that is. That's just us talking about our arrows. What do our arrows look like? All right. So first we have to say, is the degree even or is the degree odd? We have two situations. Is the degree even or is the degree odd? So if the degree is even, then we have two situations. The graph could be positive overall. It's got no negative sign in the front. It's just y equals, and then you've got your equation. And if the degree is even, then overall you're going to have this kind of shape to the graph, and your end behavior is that both arrows go up. So arrows are up, up. This is if you have a positive in front of your equation, or you have nothing in front of your equation, because we know equations don't really have a plus sign in front of them. Okay? If your degree is even and you have a negative sign in the front, then overall you're going to have this shape to your graph, and your arrows are going to go down. And this is what you would actually see, because we know that when we were writing equations for the graphs, we did have a negative equation in front of some of them, because the graphs overall did have this shape of being upside down. Okay. For the odd degree, we have the same thing. If the overall graph is positive, there's no negative in front of the equation, then that means that the graph is going to do something like this. It's going to be a positive slant. So the first arrow is going to go down, and the second arrow is going to go up, like that. If the graph has a negative in the front, then that means the first arrow is going to go up, and the second arrow is going to go down. Okay, so we're going to look at all these things, and we're going to use this information to help us draw sketches of these graphs. So let's go ahead and turn to the next page where it has some equations. So the first thing we're going to do is we're going to look at our equation. We're going to see what the degree of the equation is. So if I look at this one, it doesn't have an exponent at all. And if it doesn't have an exponent, that means that it has an exponent of 1. Because an exponent of 1 is the only exponent you don't have to write. So this one has an exponent of 1, exponent of 2, exponent of 3. So if we want to know the degree for number 1, we just have to add all of those exponents together. So if we add 1 plus 2 plus 3, what do we get? 1 plus 2 plus 3, we get a degree of 6. Okay? Now if I look in the front, is this a positive graph or a negative graph? Is there a negative sign in the front? This is a positive graph because there is no negative sign in the front. Okay, so I'm going to look at the front of my notes. I can see that overall this graph is an even exponent because it was 6. And overall, this is a positive graph because it did not have a negative sign in the front. So overall, this graph is going to be a U shape, and it's going to have both arrows going up. Okay, so the end behavior is that both arrows go up. Does that make sense? So it's a U-shaped graph because it's an even degree, and it's positive. Both arrows go up. So I'm going to write a little note to myself. This graph is going to do something like this. Both arrows going up. And now what I'm going to do is I'm going to write down each individual x-intercept that I have to draw. So I have an x-intercept of just x. Does anyone remember what number it is when it's just x? Not 1. 0. Yeah, it's 0. Okay. X equals 0. What about this one? X equals not -3. +3. It's always the opposite sign. And then x equals -5. Okay. And then for each of them, we need to know what the multiplicity is, because when we draw that x-intercept, we have to know, does it go straight through the graph? Does it bounce when it hits the graph? Or does it squiggle through? So this first one is a multiplicity of 1. This one is a multiplicity of 2. And this one is a multiplicity of 3. So I'm writing down the multiplicity at each. Okay, so now I'm going to put the markings on the graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've got an x-intercept at 0, an x-intercept at 3, an x-intercept at -5. I know that overall my graph is going to be a U shape that goes with the arrows up, up, and up. Okay, so for my first equation, or for my first x-intercept, my first x-intercept is at -5. -5 has a multiplicity of 3. So what I have to do is I have to look at my options for a multiplicity of 3, and I have to picture the one that makes the most sense. So I have two options. From the arrow, I can go down, level off, go down. That's one option. Or from the arrow, I can go up, level off, go up. Which one made more sense? I have this arrow. Does it make sense to go down, level off, go down? Or using this arrow, does it make sense to go up, level off, go up? Which one makes sense? Should I go down, level off, go down if I want to connect to the arrow? Or should I go up, level off, go up? I should go down. So I'm going to start with the arrow. Okay, now that one makes sense because if I was to go up, I would have to cross back over to connect to the arrow, and that would be weird. Does that make sense? So when you do this, you're always going to have two options, because when we draw our multiplicities, we always have, like, for the bounce off the x-axis, we can bounce above, we can bounce below. For the straight through, we can straight through this slant or this slant. When we have the squiggle through, we can go up, level off, go up, or we can go down, level off, go down. We have two different ways of doing all of these. So I'm always going to draw the two options, and then one of the options is going to make sense, and one of the options isn't really going to make sense. Okay? So we always just go with the one that makes the most sense. So here, going down connected really well to the arrow. Going up, you could do it, but it doesn't connect to the arrow very well. And that's how you know that's not the one you should go with. Okay, let's try the next one. The next one is through 0. It's a multiplicity of 1. So here I have to connect to my first curve. Okay, so I have two options for a multiplicity of 1. I can draw my slant like this. That's my first option. Or my second option is I can draw my slant like this. Which one would connect to the green better? Should I draw my slant like this to connect to the green? Or should I draw my slant like this to connect to the green? First one or second one? Connect my slant like this, or connect my slant like this? First one, okay? So I'm going to connect my slant like this. And if you guys notice, the green connects to this really nicely. If I had connected to the other one, I would have had to cross up here to connect to it. And when I connect up there, I make an extra x-intercept that's not in the equation. That's how I know I shouldn't do the other one. Okay? All right. Let's try the next one. Okay, the next one is an x-intercept of 3. This has a multiplicity of 2. The multiplicity of 2 is the U shape. I have two options. I can have a U shape up here, or I can have a U shape down here. This time I have to connect to the blue, and I have to connect to the arrow. So do I want a U shape above or a U shape below? Above. I want a U shape above. So the U shape above will connect to the arrow, and then I just make sure it connects nice to the blue. There we go. And when you draw this, you should have nice, just smooth curves all the way through. You shouldn't have any corners. Okay, let's try another one. So if I look at number 2, this one doesn't have a degree on it, so I'm gonna, or it doesn't have an exponent on it, so I'm gonna put an exponent of 1. To find my degree, I add my exponents together. So what is the degree overall for number 2? 3. 2 plus 1 is 3. Okay, so my degree is 3. I have a negative in the front, and I have an odd number for my degree. Okay, negative in the front and an odd number for my degree. So I'm going to look at this. I have an odd number for my degree with a negative in the front. So this is what my arrows are going to do. They're going to go up first, then they're going to go down. Okay, so I'm going to draw a little sketch of that so I don't forget. My arrows are going to go up first, and then they're going to go down. Okay. What x-intercepts do I have? I have 2 of them. 0 and -5. 0 has a multiplicity of 2. -5 has a multiplicity of 1. Okay, so I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's -5. There's 0. I know my first arrow is going to go up. I know my second arrow is going to go down. Okay, so the first x-intercept I see is at -5, and it's a multiplicity of 1. So I have 2 options. When I draw my line through -5, my line can go like this to connect to my arrow, or my line can go like this to connect to my arrow. Which one? First one or second one? The second one makes more sense. Okay, so I'm going to draw my line like this. There's my arrow. Okay. For the next one, we have 0 with a multiplicity of 2. The multiplicity of 2 is the bounce. Okay, so I can have my bounce above, and the bounce has to connect to the green and it has to connect to the arrow. So I can have my bounce above, or I can have my bounce below. Which one makes more sense? Below. I got to have the bounce below. So there's my bounce below. And then I'm always going to make sure that when I connect these, I have smooth curves connecting them. So I shouldn't see a straight line like this. I shouldn't see corners. I should always see smooth curves connecting these two together. Like that. And if you want, you can go back and erase these other ones, or you can leave them. That's fine with me. Okay, let's try the next one. What's the degree for number 3? 4. The degree is 4. Okay. Is this graph positive or negative? Positive. It does not have a negative in the front, so it's positive. Okay. Is it even or odd? Even. It has an even degree. It's got no negative in the front, so this is positive. Positive coefficient, even degree. So overall, it's going to be shaped like this. Both arrows are going to go up. Okay, so this is what we've got overall. All right, what x-intercepts do we have? -3, +4. They both have a multiplicity of 2. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Both arrows go up. So we start with -3. It has a multiplicity of 2. So should we draw the U shape above or draw the U shape below? Which one makes more sense? Above. Above makes more sense. Okay. All right, and then for this one over here, we have to connect to the green. We also have to connect to this arrow. It's a multiplicity of 2, so that's the U shape. It's going to bounce when it hits the x-axis. Should we draw the U shape above, or should we draw the U shape below? We should draw it above again. So above. Okay. And then when we connect them, we make sure that they've got a smooth curve. And you can go back and erase the other stuff or leave it. Doesn't matter to me. Okay. What's the degree for number 4? 5. The degree is 5. Okay. Positive or negative? Negative. It's got a negative sign in the front. Okay. So we have an odd number for the degree with a negative coefficient. So the first arrow goes up, the second arrow goes down. First arrow goes up, second arrow goes down. Okay. What are the x-intercepts? 0 and 7. Okay. 0 has a multiplicity of 3. 7 has a multiplicity of 2. Okay. So first arrow goes up, second arrow goes down. Okay. So 0 has a multiplicity of 3. We have two options. We have to connect to this arrow. We can go up, level off, go up, or we can go down, level off, go down. First one or second one? We can go up, level off, go up, or we can go down, level off, go down. The second one, okay? So down, level off, go down, okay? 7 is a multiplicity of 2. So that's the bounce. That's a little U-shaped graph. So we can have our U-shape be above the line, or we can have our U-shape be below the line. Below makes more sense. Okay. And then we'll connect these together. All right, what do we do with all these parentheses that don't have exponents? What do we put? We put a 1. So we got a 1 and a 1 and a 1. Okay, I want you guys to write down what the degree is. Find the degree for number 5. What is the degree? Six. Okay. All right, and then don't say it out loud. I want you guys to figure out which way the arrows go. So look at the front of your notes, look at the degree, look in the front of the equation, see if there's a positive or a negative, and figure out which way the arrows should go. Degree is 6, that's an even number. Look at the front of your equation, determine which way the arrows should go. All right, anyone want to say what they found? What should the arrows do? So I heard they're both supposed to go up, and you said they're both supposed to go down? Okay, both up, both down. Do we have votes on which one is right? So you guys are both in agreement they're even, right? Both up or both down is even. What would make the difference about if they're both up versus both down? If they were going down, it would be a negative. So what do we conclude? They both down. Yeah. Yep. You need her? So if there is a negative in the front, what do we do? That means they're both down. Okay? All right, I want you to take a moment and write down what each of your x-intercepts are. Go ahead and take a moment, write down each of your x-intercepts. And then for each x-intercept, we have to write down what the multiplicity is. For each x-intercept, we have to write down what the multiplicity is. There is no 0 because there's no x in the front. Yeah, so there's only a 0 if there is an x. Okay, so we've got -5, -1, +2, +5. Both of our arrows are going down. All right, so at -5, we got two options for our multiplicity of 1. Our slant can go this way, or our slant can go this way. Which one is it, first or second? Our slant can go this way, or our slant can go this way. First or second? The first one, okay? So our graph is going to slant like that. All right. For -1, we have a multiplicity of 1 again. So we have two options. Our slant can go this way, or our slant can go this way. Which one should it be to connect to the green? Our slant can go this way, or our slant can go this way. The second one, okay? So our slant is going to go like this. All right. Next one is our multiplicity of 3. So for 2, we have a multiplicity of 3. So we've got two options. We have our graph can go up, level off, go up. That's one option. Or our graph can go down, level off, go down. So up, level off, go up. Or down, level off, go down. We still feel good about the first one? Okay. So we're going to go up, level off, go up. Okay. And then our last one is another multiplicity of 1. So we got two options. We can slant like this, or we can slant like this. The second one. Okay. And that was perfect. That was exactly how it should be. Okay, so I'll erase all the extras. So you will know that you got it right if you don't cross the x-axis anytime extra. You don't have any extra places where you cross the x-axis. If you don't draw going backwards, you should never have to draw going backwards to go to the next one. That sort of thing. It should make sense when you're done. Okay, let's do one last one. What's the degree for number 6? Degree for number 6 is 9. Right? We got a negative in the front. 9 is an odd number. So what are the arrows doing? Odd number, we got a negative in the front. What do the arrows do? So it goes like this. It goes up and down. So which, does it go up first or does it go down first? It goes up first. Okay, so it goes like this. Okay, perfect. All right, so we got that. What are the x-intercepts? 0, -4, and 2. And then what is the multiplicity for all of the x-intercepts? 3. We got a multiplicity of 3 for all of them. Okay? Okay, so we got -4, we got 0, we got 2. Got an up arrow first, then we got a down arrow. Okay. All right, first thing. So for -4, we got a multiplicity of 3. Should we go up, level off, go up to connect to the arrow? Or should we go down, level off, go down? Go down, level off, go down. Okay. So down, level off, go down. All right. For 0, should we go up, level off, go up? Or should we go down, level off, go down? Up, level off, go up? Or down, level off, go down? Okay, we're going to go up, level off, and go up. Okay, and we know that was the right choice because it connects well to the one before it. Okay, for the next one, should we go up, level off, go up? Or should we go down, level off, go down? So we're going to go down, level off, go down, and then those connect. And I can erase all the parts I didn't use. There we go. All right, how do your brains feel? Brains are okay? You making sense? All right, so I'm gonna hand out the assignment. The assignment just has you doing this. Same thing, more times. When you're gonna do the first page, 1 through 10. 11 is a challenge problem. It's not really a true challenge problem because you'll realize that the only way that they truly make these more complicated is they just give you more of them and you go like, oh, this problem is annoying, but it's not impossible. They just like give you a bunch of them. This problem, these two problems, 12 and 13, these are actually more challenging only because they are not factored yet. So you can't actually see what the x-intercepts are because they're hidden inside the factors. So we're going to focus first on 1 through 10. If we get through 1 through 10, we're going to try 11, which just has extra x-intercepts. And then if we get through those okay, then we're going to try these ones where we just have to factor so we can see what our x-intercepts are. Okay? If you feel intimidated by 12 and 13, we can definitely do those together. All right? So we're starting off with 1 through 10. I'm going to go ahead and pass these out. This is the last thing we are learning this unit, which means after this we're going to review and then we're going to test. Okay? Just a heads up. This is the last thing we're learning this unit.